Hello guys, welcome back to TestprepKart YouTube channel. In this video, I am going to explain the conic sections. Basically, you already know how to master the geometry portion. I already explained. First of all, you have to study the straight lines and pair of straight lines. After this, you have to study the conic sections. If you understand the conic sections, it is very easy for you to score plus 12 marks in this geometry section. Because after watching the straight lines and pair of straight lines, there is a conic section chapter. This conic section is a bunch of 4 important chapters. The 4 chapters are circles, parabola, ellipse and hyperbola. These 4 are the conic sections. The doubly headed cone has been bisected by a plane and formed the 4 important topics, that is 4 important shapes, that is circles, parabola, ellipse and hyperbola. I will discuss everything you want to know that is about the conic sections. In this video, I will explain the tangent equation, normal equation, how to memorize the equations and how many parabolas are present, how many different type of parabolas, how many different types of hyperbolas and ellipse are present, and I will discuss the circle equations. Everything you will be going to know after watching this video. So this video will consist everything about the circles, parabola, hyperbola and this ellipse. The results are also discussed here. So watch till the end, and after watching this, I will be very sure that you will be going to get everything the important concept from the topics like ellipse, hyperbola and parabola and circles. So watch till then, and if anyone didn't subscribe to this channel, subscribe to this channel, because this video will definitely guarantee you plus 4 marks and plus 8 marks. It is very important to watch this video. Now let's get into this video and discuss the conic sections. This is a conic sections, and one thing I want to explain, that is the conic sections we got by sectioning the that is this cone. Very important. These are the 2 cones. These 2 cones are inserted like this, that is a reverse. These 2 cones are inserted like this, and these 2 cones, when you observe very carefully, these 2 are touched with the vertex, these vertices. And when this is obtained according to the plane cutting, that is when we take a plane which is of the shape like this, if I cut this cone at different angles, I will obtain at different angles you will get different sections. At different sections you will get different shapes. In that shapes there are we will get 4 shapes, that is circle and parabola, circle, parabola, ellipse, circle, parabola, ellipse, hyperbola. Circle, parabola, ellipse, hyperbola are the 4 shapes you will get when the cone is bisected by a plane. If you observe here, it is mentioned in the TestprepKart mind map, that is the circle, ellipse, parabola, hyperbola are known as conic sections. Why? Because they are obtained, because they can be obtained by as an intersection of plane, that is plane is intersecting. For what? Doubly napped right circular cone. This cone is called doubly napped cone. Why? Because there are 2 cones. It is napped doubly at the vertices. Yes, doubly napped cone. And from the figure, if you observe the figure, this plane, this is the, if you observe this figure, at different sections, section will represent circle if beta equal to 90 degree. The beta angle, if you observe, if I zoom here, if you observe carefully, this is the beta angle. This is the beta angle. If this beta angle is equal to 90 degree, it will represent a circle. And if this beta angle is equal to, that is alpha less than beta, and it is less than equal to pi by 2, then we will get the ellipse. And when it is equal to beta, you will get parabola. And when this beta lies between the alpha and beta, you will get hyperbola. This is the theory part, but there is no need to remember at what angle you will get the what section. But it is very important where you have got it. That is, you have got it from the doubly napped cone. In that cone, if the plane is bisected that cone at different angles, with respect to the different angles, different sections are formed. Suppose if I take this as this thing, and if I cut this pen horizontally, what a section I will got? I will get a circle. Like this only, at different angles you will get different shapes. If I cut like this, the shape obtained here is parabola. If I cut suppose at an angle you can take less than pi by 2 and greater than alpha, if I consider, if I cut this one, I will get one ellipse here. But this is a shape of pen. You will get different angles, but at different angles you will obtain different shapes. But if we take the doubly napped cone and do the intersections with the plane, you will get the shape circle, parabola, ellipse, hyperbola. Now I will discuss each one. That is, first of all, I will discuss the circle. After the discussion of circle, entire thing I will discuss. First, very important, first section I will discuss as circle. In this this single one video, you will get all the 4 things, that is circle, parabola, ellipse, hyperbola, the main important concepts. First of all, I will discuss the circle. What is a circle? The circle definition is, it is a locus. It is a locus of a point. It is a locus of a point which is, it is the locus of a point. It is a locus of a point which is moving in a plane from a fixed point, and moving at a fixed distance. It is called a circle. So if we observe, this is the fixed point. If I take another point which is moving in this entire plane, and how it is moving? By keeping the constant distance from the fixed point. If it is r from the fixed point, it should move with the r distance only. And it should move the entire rotation. If I move like this, and this entire distance is r, and r. If you observe very carefully, if the fixed point and there is a point moving, if I move like this only, that is, if I fix this point and if I move like this only, this entire rotation after one cycle, what I got the figure, the section which I got here is called circle. This is a main important thing. And suppose if I take this as, this is a center, the fixed point is called center here. The fixed point is called center, and the r which we consider is called radius in terms of circle here. And the center, if I consider the point as x comma y, yes, no, I will consider it as first it as origin, so that you can understand easily how the equation is transforming. If it is considered as 0, 0, that is, origin is considered as 0, 0, and this is a radius r. What is the equation of the circle? Suppose the moving point is x comma y. So that I can know what is the distance between the origin. The origin O is 0, 0, and the point here is x comma y. Yes. If I join these 2 points, this distance is r. Can I relate these two? Yes, we already know the distance formula. What is the distance between the origin and the x comma y point? The distance is root of x minus 0 whole square plus y minus 0 whole square is equal to r. Yes, this is a r. But when I open x square plus y square is equal to r, I will get x square plus y square is equal to r square, which is known as the equation of circle. This x square plus y square is equal to r square is known as circle equation. When you write a circle equation, you have to understand what is the center. What is the center of the circle? It is 0, 0, which is origin, because it is placed at origin as a center. Yes, 0, 0. And what is the radius of the circle? The radius of the circle is r. Very important. Suppose if the center is not at the origin, if it is somewhere, that is x1 comma y1 is the center now. Now the equation transforms simply by shifting the origin, that is x minus x1 whole square plus y minus y1 whole square is equal to r square. This is the main important thing you have to understand. X minus x1 whole square plus y minus y1 whole square is equal to r square. In this equation, what is the center? The center of the circle is x1 comma y1 and the radius is r. Radius is equal to r. This is the main important thing you have to understand. What are the 2 main important things I discussed? If the circle is at the origin center, you will get the equation as x square plus y square is equal to r square. Now, if the center is not at the origin, if the center is somewhere, that is x1 comma y1, you will get radius. You will get radius as radius is equal to r. Both the cases the radius is equal to r, but the point is shifted from center, that is 0, 0 to x1 comma y1. This is the thing you have to understand. And there are several types of circle equations. What are the several types of circle equation? When the circle is located at different positions, that is, if it is located at origin, it is the equation x square plus y square plus is equal to r square. It is origin centered. If it is centered at x-axis, that is, if the center present in x-axis, what the equation changes? If it is present in x-axis, suppose if this is the equation, if this is a circle which is centered at x-axis, this equation is x minus h whole square plus y minus k whole square is equal to the radius. We can eliminate r and just take a h comma k. values only. Why? Because if you observe, the distance which are moving from the x-axis is called the y value, that is k. So that radius is k only here. So in order to eliminate the one variable, we are taking the radius as k only. And if it is centered at y-axis, what we can do? We can represent here, and this radius now becomes h, that is x minus h whole square plus y minus k whole square is equal to h square. If it is touching both axes, if both axes are touched, that is if both axes are touched, the circle equation can be x minus r whole square plus y minus r whole square is equal to r square. That is, this r will be equal, because this is the distances will be equal. This is r, this is r. So the radius will be r, the center will be r. These are the things you have to understand. And there is another equation, that is diametric equation. Diametric equation of circle. What is the diametric equation of circle? That is when the ends of the diameter are given, that is x1 comma y1 and x2 comma y2 are the ends of the diameter. If these are the ends of the diameter, we can form the circle by using these 2 points, and the equation becomes x minus x1 into x minus x2 plus y minus y1 into y minus y2. This is the diametric equation of the circle. That is, when the ends of the diameter are given, we can form the circle. That is x minus x1 into x minus x2 plus y minus y1 into y minus y2. This is the diametric equation. And there are some important points in the circle. The important points will be the parametric coordinates. Parametric coordinates. What are the parametric coordinates of circle? That is x square plus y square is equal to a square. In order to write the parametric coordinates of any curve, one thing we should remember, that is we have to substitute the x point in such a way that we can find the y. If I substitute x as a cos theta, I can find y. The y will be a sin theta. Yes, if I substitute both the points, what I will get? I will get a square cos square theta plus a square sin square theta is equal to a square. So a square will get cancelled, and I will get sin square theta plus cos square theta is equal to 1. Yes, to get this relation, I have to substitute a cos theta, a sin theta. So the parametric coordinates of a circle will be a cos theta comma a sin theta. Yes, very important. This is the parametric coordinates, x square plus y square equal to a square. I will get a cos theta comma a sin theta. These are the parametric coordinates of a circle. And now comes the intercept. What is the intercept concept? If I discuss the x-intercept of the circle, what is x-intercept? If I take this as circle, yes, if I take this as circle, this circle, suppose it is like this. If this is axis, this is x-axis, and if it is this as y-axis, you can observe this circle is cutting the x-axis at these points, and the length of this one, this entire length is called x-intercept, and the value of x-intercept is equal to 2 root g square minus c. And one more thing I forgot, that is the circle equation. General equation can be written as x square plus y square plus 2gx plus 2fy plus c is equal to 0. In this equation, the center is equal to minus g comma minus f, and the radius is equal to root of g square plus f square minus c. This is the results you have to remember. Suppose if I take the example x square plus y square plus 4x plus 6y plus 3 is equal to 0. Suppose this is a circle equation, and you have to find the center. How you can find the center? Simply divide the given value of x coefficient by minus 2. That is 4 by minus 2, 6 by minus 2. This is a shortcut. You will get minus 2 comma minus 3 as a radius. That is the center. And the radius, I already said, what is the radius? The square of the center, that is 2 square minus 2 square plus minus 3 square, and you have to subtract this one. You have to subtract the constants. What you will get? You will get root of minus 2 whole square, it is 4, 3 square, it is 9, minus 3. You will get root 10. Yes, because 13 minus 3 is 10. So root 10 is the radius. Like this you have to calculate. Here the x-intercept equal to 2 root g square minus c. Suppose the circle is like this. It is cutting the y-axis. So this length can be calculated as y-intercept. This length is calculated as y-intercept, and the y-intercept value is 2 root f square minus c, and f is a quotient of y here in the equation, and g is a quotient of x in the equation. Yes. And let's come to the important thing, that is position of point. Position of point with respect to circle. That is, if this is a circle and this is the point p x comma y, where we have to place the point? the point placing can be at 3 positions. It is outside, this is inside, this is on, this is inside. Yes, the point can be situated at 3 different positions, that is inside the point, outside point, and on point. So the circle equation, yes, we have to denote the notation. S is equal to x square plus y square plus 2gx plus 2fy plus c is equal to 0 is a s value, that is the representation. And s1, if I represent s1 like this, the x1 is simply substitute the given point, x1 square plus y1 square plus 2gx1 plus 2f/1 plus c is equal to 0. Not 0, it has some value. Definitely it has some value because we are substituting the point. Depending on that value, if this s1 is greater than 0, s1 less than 0, s1 equal to 0. If it is equal to 0, it is satisfying the circle. So we can say s1 equal to 0 is the on point, on circle. And if s1 less than 0, what is s1 less than 0? The s1 less than 0 point is the inside point. Inside point. And when s1 is greater than 0, what you will get? You will get s1 greater than 0 when we will get s1 greater than 0. We will get s1 greater than 0 when we can say this is outside. This is outside point. It is very important. And I think I have explained this one. That is this is important, I have explained, and this thing I have explained, and this thing I have explained. So a circle I have explained, I think. And in this the conic section important facts also. The standard equation I have explained. When the ends of the diameter are given, I have explained this is the equation, and the general equation of circle is this one, and the circle center and radius I also explained. So I think the circle part is completed. That is, I have explained everything. I think this block is completed. This block is completed. And in the important facts block, I have completed a circle. So entire conic section is completed. Here, that is the circle part is completed. Now I will discuss the parabola. That is here parabola. What is parabola? A parabola is a set of all points in a plane that are equidistant from a fixed line and a fixed point in a plane. Fixed line is called directrix of the parabola, and fixed point f is called focus. And a line through focus and perpendicular to directrix is called axis, and the point of intersection. I will explain this everything. First of all, understand guys, the parabola shape is this one. Why it is parabola? Because if I take any point in this parabola and find the distance between the fixed line and the ratio and the fixed point, this is a point P. If I take this distance and this distance, suppose if it is f, d by f is equal to 1. If this ratio is equal to 1, it is called as parabola. And what is the ratio we are dealing? It is called eccentricity. E is equal to 1. If E is equal to 1, it is called as parabola. That's it. And the parabolas are of 4 types. The first parabola will be this one, and the second parabola will be this one. That is right opening, left opening. And the third parabola can be upward, and the fourth parabola can be downward. Now, what are the important things? If this is the right opening, it has some fixed point which is called as focus. Yes, it is a comma 0 in case of this this equation, that is y square is equal to 4ax parabola. This is, and this parabola is y square is equal to minus 4ax parabola. And the third one, it is y square, that is it is x square is equal to 4ay parabola, and this one is x square is equal to minus 4ay parabola. But different parabolas, we have different focuses and directrix, and this is called as directrix, it is called as fixed line, and the equation of this is x is equal to minus a. And for this, the focus will be minus a comma 0, and the directrix is x equal to a equation. And the line which is passing through the parabola, that is it at which it is cutting the x-axis, this point is called vertex. It is called as focus, and it is called as axis, which is passing through the parabola. And the line which is passing through the focus and perpendicular to the axis, it is called as latus rectum. Latus rectum. And the length of latus rectum is equal to 4a. Very important result. Everything, there it is 4a only. There is no change. Here the directrix equation is for y square, x square equal to minus 4ay equation. The directrix equation is very important. Here it is y is equal to y equal to minus, I think it is a plus b. I think it is y equal to plus a, because we are dealing with a. Here you will get the directness equation down, that is y is equal to minus a. The vertex will be 0, 0. The focus will be 0, comma a. And here the focus will be 0, comma minus a. Everything there are slight changes. This is the main important thing you have to understand. The focus, vertex, latest rectum length, everything I have discussed here only. That is, what is the focus? The focus is a comma 0 here, but here it is minus a comma 0. Here it is a 0 comma a, here it will be 0 comma minus a. So there are 4 types of parabolas. The first parabola is y square equal to 4ax. The second parabola is y square equal to minus 4ax. The third parabola is equal to x square equal to 4ay. And the fourth parabola is equal to x square equal to minus 4ay. Now I will discuss the parametric coordinates. Parametric coordinates, which are the important concept? Parametric concept, that is, there are 4 different parametric coordinates for 4 different parabolas. For y square equal to 4ax, for y square equal to minus 4ax, for x square equal to 4ay, and x square is equal to minus 4ay. There are 4 types of parabola. For different parabolas, we will have different coordinates. So what I said for parametric concept, we have to substitute the value of x and we have to get the value of y. So if I substitute the a value as at square, y square will becomes 4at square, 4a square t square. So if you observe very carefully, I can get y value as 280. So 80 square comma 280 is the parametric coordinate for y square equal to 4ax. And here if I substitute minus 80 square, I can get 280 because I have to make this positive, because if it's a square, it cannot be negative. So minus 80 square comma 280 is a parametric coordinate. For this, it will be 280 comma 80 square. And for this, it will be 280 comma minus 80 square. Why? I have to make this as positive. So these 4 are considered to be parametric coordinates. You have to remember. You have to remember this one. Suppose this is a parabola. In parabola chapter, the important parabola is y square equal to 4ax. For this parabola, the important thing is the position of point. Position of point. Suppose there is a point x1 comma y1. I have to check whether this point is on the parabola, outside the parabola, or inside the parabola. How I can check? I can check by simple notation. That is y square minus 4ax equal to 0 is a notation. What is s1? S1 is, I want to substitute this point. y1 square minus 4ax1. I have to find this value. Suppose s1 is greater than 0, s1 is equal to 0, s1 is less than 0. For s1 is equal to 0, it is on the parabola. For s1 greater than 0, it is outside the parabola. Outside the parabola. For s1 less than 0, it is inside the parabola. Yes, this is a thing you have to understand. And if you observe in the mind map, they have explained that one only. Forms of parabola, there are 4 types: y square equal to 4ax, y square equal to minus 4ax, x square equal to 4ay, x square equal to minus 4ay. And what is axis? The axis here is, at right opening parabola, the axis is y equal to 0. At y square equal to minus x, it is also same, y equal to 0. But at this parabola and this parabola, if you observe, the axis is x is equal to 0. And the axis here is x equal to 0 for downward opening parabola also. Yes. And the direct equation I already explained, the vertex I already explained, focus I already explained, that is x equal to minus a, x equal to a, y equal to minus a, y equal to a. These are all the this one direct equations. And the vertex are 0, 0, 0, 0, 0, 0, 0, 0, because the vertex is same, because it is passing through origin. If it is other than origin, we can represent the equations. The 4 equations can be represented as y minus k whole square is equal to 4a into x minus h. If it is h comma k shifted, that is the vertex is h comma k, the new equation will be like this. You have to understand. And the focus is completed, the length of the latest rectum I already completed, that is x equal that is 4a, 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 4a. It is a constant length because the latest rectum length is not changing here. It will be 4a in all the 4 parabolas. And the equation of the latest rectum, is simply the focus. Suppose this is the parabola and I already said it is passing through focus. So if it is passing through focus, how it is the equation? X is equal to a is the equation. So x is equal to a, x is equal to minus a, that is the reciprocal of this one. That is the directrix equation reciprocal will be the equation of latest rectum. Because if you observe very carefully, I will explain here. For y square equal to 4ax equation, what I said, the directrix will be left side. So x is equal to minus a is a directrix. Yes, but the latest rectum equation will be x equal to plus a. So it is the opposite of the directrix equation. So this entire things are completed. I think the parabola, this block is completed, but I will check the important facts for this this thing. The important facts will be the tangent things. I will explain the tangent. I think I have to explain here. The slope form I have to explain, and the normal also. I will explain the 4 things. First of all, I will explain this thing, that is y square equal to 4x. For this parabola, I will explain the tangent. How to write the tangent equation. Very important. To write the tangent equation, there are 3 things. That is, in 3 formats we can write. That is the point form, and the second, one is point form, one is parametric form, and another form is slope form. These 3 forms you have to understand how to write. First thing is point form. What is point form? That is, if one point is given x1 comma y1, you have to write the tangent equation. Now the tangent equation will be the transformation of this equation. How will we have to transform? The transformed equation is said to be t, and it can be written by simply interchanging. That is, y square equal to y by 1, and x square is equal to x1, and x is equal to x plus x1 by 2, and y is equal to y plus y1 by 2. If I take this one, that is x, y, and x square and y square, I can find the tangent equation. So the now tangent is equation will be t is equal to, simply substitute, that is y square can be written as y by 1 is equal to 4a into x plus x1 by 2. That is, y by 1 is equal to 2a into x plus x1. So this is the equation of tangent for x square equal to y 4ax at the point x1 comma y1. What is the parametric form? I already said what is the parametric equation, parametric coordinates of y square equal to 4ax. It will be 80 square comma 280. So the point x1 comma y1 now be substituted as 80 square comma 280. Simply in this equation only, if I substitute y by 1 is equal to 2a into x plus x1. If I substitute this point, what I will get? I will get 2at y is equal to 2a into x plus 80 square. Yes. So this 2a will get cancelled. So ty is equal to x plus 80 square. Yes. So this ty is equal to x plus 80 square is the tangent equation. This is a tangent equation, and here t is a parameter. And if it is a slope, you have to find the relation. Suppose, how we can find the relation of the slope? We have to find the relation between t and m. How we can find? We can find like this. Suppose there are two points I taken in the parabola. If I want to find the slope, that is 80 square comma 280 is 1 point. 80 square comma 280, that is 81 square comma 82 square is 1 point. And another point, it is 82 square comma 282. If these two are the points, I have to find the relation between. Now I want to find the relation between these two. How I can find? I have to think. This one very important. The equation is y square equal to 4ax. In this equation, if one point is 80 square comma 280, suppose this is a point in this parabola. That is, I already said this is the parametric coordinate. Now, if you observe very carefully, y square equal to 4x is the equation. Now, I want to find the slope. If I want to find a slope, I have to differentiate. 2y dash is equal to 4a. Y dash is equal to 4a divided by 2y. So, I have to substitute this point in order to calculate the slope. So, 4a divided by 2 into 280. How much I will get? I will get 1 by t. Slope y dash is equal to m, and 1 by t I got. So this is a relation between m and t. So simply substitute t is equal to 1 by m and find the equation here. What I will get? I will get y by m is equal to x plus 1 by m square. If I solve, what I will get? I will get y by m is equal to x m square plus 1 by m square. Yes, cancel. So my is equal to x m square plus 1. So y is equal to mx plus 1 by m. I think it is 1 by m square. That is 1 by m. Here 1 we have considered because it is a. I think it is a. So the equation will be sorry guys, here there is a here. So that is the reason we got a here. Yes. So the final equation is y is equal to mx plus a by m is the equation in the slope format. Yes. For normal, what is the equation of normal for y square equal to 4ax? Yes. The first one is point form. What is the point form? The point form will be here, if I calculate y square equal 4ax and take ax 80 square comma 280, what I will get? I will get for point form, suppose x1 comma y1. What is a normal first of all? Suppose at this point if I draw the tangent, the perpendicular is called the normal. Yes? For the point form, what I said, the transformed equation, that is y1 minus 2a into x plus x1 is equal to 0 is the tangent equation. Yes? So in this tangent equation, if you observe, this is a transformed equation. And now I want to write the this thing. What is the equation of I think it is in the important facts. The equation of the normal at the point x1 comma y1, it is the slope we have to find. It is a slope, that is the equation will be y minus y1 is equal to, that is if x1 comma y1 is a point, at that point if you want to write the slope, that is y1 minus y1 is equal to you have to calculate the slope, that is y1 by 2a into x minus x1. Yes, this is the answer. So this thing is completed, and the equation of the slope m, when it is in the parameter m, you can write as y is equal to mx minus 2am minus am square. Like this you have to write. And if it is in the parametric form, it will be y is equal to minus tx plus 280 plus 80 square. So like this you have to write. And when it is in the parametric, when it is in the slope form, there is no point of contact. In the point form, it is x comma y, x1 comma y1, and for this parametric it is 80 square comma 280. But there is no point of contact. In order to find the point of contact, in this point only, I can substitute t is equal to 1 by m. Yes, and I will get a by m square comma 2a by m. This is the point of contact in terms of slope, so that the slope equation of the tangent have the point of contact also. So this block is also completed. So I think the parabola has been completed. Now I think we have to discuss the ellipse. This entire portion I will discuss at once, so that you can understand. So basically I have to move here. There are two types of ellipse. The first equation is x square by a square plus y square by b square is equal to 1. This is one equation. And another equation also, x square by a square plus y square by b square is equal to 1 only. But what is the change here? Here it is a greater than 0, a greater than b. Here it is a less than b. Now comes the important properties. How it looks like? Here it looks like this, and here it looks like this. I am writing the comparison so that you can understand easily. Here the values are a comma 0, and here the value is a minus a comma 0. Here this is the directrix and this is the directrix, and here there are two focuses, s1 and s2. Yes, and this is called 0 comma b, and it is called as 0 comma minus b. These are the simple representations. Here also 0 a comma 0, here also minus a comma 0, here it is 0 comma b, and here it is 0 comma minus b. Yes, 0 comma a, 0 comma b, 0 comma b. Yes, now here the directrix are, this is the directrix and this is the directrix. Yes, these are the directrices. Now comes the important point. Here what is a vertex? Now here it is not the vertex, here it is a center. Center is equal to 0 comma 0. And what is the vertices? Vertices is equal to plus or minus a comma 0, because these are the vertices. And what is the focus here? S1 S2 is equal to plus or minus ae comma 0 here. But here what is the center? Center is equal to 0 comma 0, same. But the vertices here, it is here, this one. Vertex is equal to, one second, I will verify. Yes, correct only. Here I think a vertex is equal to plus or minus 0 comma plus or minus b. Yes, and what is the equations here for s1 and s2? This s1 and s2 here. Yes, this s1 and s2 will be plus or minus 0 comma plus or minus be. And what are the directrix equation in the case of first ellipse? In the case of first ellipse, the directrix equation equal to x is equal to plus or minus a by e. But in this case here it will be x is equal b, y is equal to this thing, y is equal to plus or minus b by e. This thing you have to understand. These are the some changes. And this length here, this length is called major axis length. Major axis length. So this length is equal to 2a, and this length is equal to minor axis length, it is called 2b. Here the major axis now becomes this one. This is the minor axis. The minor axis length is equal to 2a here. Minor is equal to 2a, but the major axis will be 2b. These things you have to understand. And one important result in the case of ellipse is That is, if I take the ellipse again here, suppose this is S1 and this is S2. If I take the point P here and if I join, this length PS1 plus PS2 is equal to 2A, which is equal to major axis length. This is major axis length. Very important. The major axis length, that is PS1 plus PS2 is equal to 2A. Very important. And for this ellipse, again, if we discuss the position of point with respect to ellipse. If I discuss this one, what is the position of point with respect to ellipse? That is, this is the ellipse. If the point is P here, if the point is P here, if the point is P here, it is outside, it is in, it is inside, it is on the ellipse. On the ellipse, yes. How to calculate? I already said what is the equation of S? It is x square by a square plus y square by b square minus 1 is equal to 0. And what is S1? x1 square by a square plus y1 square by b square is minus 1. I have to calculate S1. Depending on S1 value, if it is greater than 0, if it is less than 0, if it is equal to 0. If it is greater than 0, it is outside point. And if it is inside point, it is S1 less than 0. And if it is S1 is equal to 0, it is on the ellipse. On the ellipse. Very important. And one more thing I forgot, the ellipse which I discussed here. In these two ellipses, there is a concept called eccentricity. Yes, because the eccentricity, it is a ratio of the distance of the point on the curve from the fixed line to the fixed distance. That ratio is called eccentricity E. If this ratio is equal to 1, it is the parabola. When it is less than 1, it is called as ellipse. I already explained. Now comes the important thing, how to calculate the eccentricity of the ellipse. But in the parabola, there is no needed because it is already calculated as 1. But in the ellipse, we have to calculate. In the hyperbola also, we have to calculate. In the ellipse, the equation is b square is equal to a square into 1 minus e square. This is the relation in the first ellipse. If it is a less than b, if it is a less than b, if it is a greater than b. When a is greater than b, we have to use this relation. But here, a is less than b. In the second ellipse, that is a vertical ellipse. In this case, the relation changes to a square is equal to b square into 1 minus e square. This is the relation we have to use in order to calculate the eccentricity. Now comes the tangent equations. Tangent equation of ellipse. There are two topics left in the ellipse, that is tangent equation of ellipse and the normal equation of ellipse. The first equation is, what is the first equation? The first equation is slope, not slope, it is point format. It is point form. One second, guys. So the point form. If the point is given x1 comma y1, suppose this is a ellipse and this point is x1 comma y1, and by using this point, if I want to draw the tangent in the point of slope, I already discussed s is equal to, what is the relation? X square by a square plus y square by b square minus 1 is equal to 0. It is a s. What is t now, which is called as tangent? T is a transformed equation. X square should be transformed to xx1 by a square plus y1 divided by b square minus 1 is equal to 0. And in the case of ellipse, the parametric coordinates are a cos theta, as same as circle only, but here it will be b sin theta, not a sin theta. If it is a, it will be the circle. Suppose if it is very obvious, if b is equal to a, here x square plus y square is equal to a square, which is a circle equation. So the difference between the circle and ellipse is only one constant, that is b. If b is equal to a, it will become the circle. So that is the reason the parametric coordinates is changed to a cos theta comma b sin theta. So this is a transformed equation. This is called as tangent equation in point form. What is the tangent equation in parametric form? In parametric form, in the parametric form, the equation is changed to, simply substitute the parametric coordinates in this equation. You will get x into a cos theta divided by a square plus y into b sin theta. Y into b sin theta by b square minus 1 is equal to 0. So a will get cancelled, b will get cancelled. You will get x by a cos theta plus y by b sin theta, and if I transfer this minus 1 to right side, I will get x by a cos theta plus y by b sin theta is equal to 1. This is a tangent equation in the parametric form. And what is the format of slope form? Slope form equation is y is equal to mx plus or minus root of a square m square plus b square. This is the equation you have to remember. Now the tangent equation is completed. Now normal equation. Now equation of normal. Simply what we have to do, the normal equations can be calculated. For the equations of normal, simply what we have to do, we have to find the normal slope. In the first equation where we have written this one, that is x1 divided by a square plus y by 1 divided by b square minus 1 is equal to 0. Now what we have to do, we have to simply write the normal equation, that is a square x by x1, which is a point x1 minus b square y by y1 is equal to a square minus b square. This is a very important equation, that is a point form of normal equation. Now parametric form. Parametric form. The normal equations are somewhat tedious, but you can remember the parametric equations. Simply substitute a cos theta comma a sin theta, b sin theta. Sorry, it is not a sin theta because if b equal to a, it is circle, but here discussing ellipse, so it will be a cos theta comma b sin theta. What you will get? You will get parametric as ax by cos theta minus by by sin theta minus by by sin theta is equal to a square minus b square. This is the equation. Now there comes the third one, that is slope. Now the slope form. The slope form will be y is equal to mx plus or minus a into, that is a m into, one second. The equation is m into a square minus b square divided by root of a square m square. Here there is a change. There is a change here. It is not a square m square plus b square. It is a square plus b square m square. It is very important. This is a minute change here. This is the slope form of normal equation. Slope form of normal equation. This is the important. The main important is the normal equation in the slope format and the tangent equation, which is again the normal the slope format only. This one is very important. These two equations you have to remember. So I think I have completed the entire ellipse. I have discussed the entire this one, the lengths and everything. And one thing I have missed, the length of the latest rectum. It will be 2b square by a. In the first ellipse, this ellipse. For this ellipse, it is 2b square by a. For this ellipse, it will be 2a square by b. These two lengths I have forgotten. So this entire block is completed of ellipse. And for the important facts also, the ellipse part, I have discussed this thing. This relation, this eccentricity relation for tangents, and this thing I have forgotten. The point of contact in the slope format I didn't discuss. The answer is plus or minus a square m by c comma minus or plus b square by c. What is c here? C is a constant in the y is equal to mx plus or minus root of a square m square plus b square. This c is same as this c. So this entire thing is a c value. This under root value here. That is plus or minus a square m by root of a square m square plus b square comma minus or plus b square by root of a square m square plus b square. So this is a point of contact, and the equation of normals I already explained. These are the normal equations. So this block is also completed. I think we have completed the circle, parabola and ellipse. Now I am going to discuss the hyperbola, which is again important. Hyperbola. Here the hyperbola is also two types. Very important. Here also the hyperbola is of two types. You can see here. You can see here there are two types of hyperbola. One second, where I have written? Here I have written. The hyperbola. Here also there are two types of hyperbola. One hyperbola is this thing. These are the directrices, and the next hyperbola is this thing, the upward. This is the hyperbola. These two are called branches of hyperbola. Branches of hyperbola. Yes, these are the branches of hyperbola, and these are the directrix equations. These two are the directories, and here the directories are this one. Now comes the discussion. What is the center? The center is 0, 0. What is the vertices? These are called as vertices. It is again 0, a, 0. That is minus a, 0 here. It is a, 0. And what is the directrix equation? This equation is x is equal to a by e, and this equation is x equal to minus a by e. Yes. And what is the length? Here there is no major axis, there is no minor axis. Here there is transverse axis and conjugate axis. This entire thing is transverse axis, and this length is equal to 2a, and this conjugate axis length is equal to 2b. Here also there is no major axis, minor axis. This length is called transverse axis. Here the conjugate axis will be 2b length, and there is 2, I think it is 2b. Not conjugate, the major axis, that is the transverse axis length is 2a here, and the conjugate axis length is 2b. I will write here transverse axis length is equal to 2a, and the conjugate axis length is equal to 2b. But here the transverse axis length is equal to 2b, but the conjugate axis length is equal to 2a. And what is the focus? The focus equations are ae, 0, and here it is minus ae, 0. And here the focus equation is 0, minus be. Here it is 0, plus be. Very important. And here the equations. First of all, I forgot to mention the equation. The equation of this type of hyperbola is x square by a square minus y square by b square is equal to 1. Here x square by a square plus y square by b square minus 1. These two are the hyperbolas. This is a hyperbola, main hyperbola. This is the conjugate hyperbola. Conjugate hyperbola. It is called as conjugate hyperbola. And one important relation in the eccentricity of these hyperbolas. Suppose the hyperbola eccentricity is E1 and this conjugate hyperbola eccentricity is E2. What is the relation? The relation is 1 by E1 square plus 1 by E2 square is equal to 1. This is a relation. Yes, and how to calculate the eccentricity of the first hyperbola? It is E is equal to root of 1 plus b square by a square. This is the relation for first hyperbola. But here the relation is 1 plus a square by b square. This is the second hyperbola. There is a conjugate hyperbola E relation. And I think I have explained the points, everything I explained about the basics of hyperbola. Now I am going to discuss the position of point. Position of point with respect to hyperbola. In everything I have discussed this topic because this topic is very important. Because in order to write the tangent equations and normal equations, first of all you have to understand where the point is located, whether it is located on, in, or outside. If it is outside, you can draw two tangents. If it is on, you can draw one tangent. If it is inside, you cannot draw tangent or normal. It is very important. Sorry, I am drawing the hyperbola. You will confuse for the hyperbola and ellipse. Position of point. Suppose if I take this hyperbola, this is inside, this is outside point, and this point is on the hyperbola. Yes, now I already said we have to write S. S is x square by a square minus y square by b square minus 1 is equal to 0. What is S1? The substituted point, x1 square by a square minus y1 square by b square minus 1 is equal to 0. Yes, not equal to 0. Very important. Every time I am doing this mistake, but you should not do that mistake. That is x1 square by a square minus y1 square by b square minus 1. You have to evaluate this value. This value cannot be 0. It can be 0, but you have to evaluate now first. So depending on value s1 greater than 0 and s1 less than 0, you have to check the things. If s1 is equal to 0, it is on the hyperbola, it is obvious. That is, it is satisfying the curve. But when s1 is greater than 0, in every case, that is circle, parabola, ellipse, when the s1 is equal to greater than 0, what I said, it is outside point, but here it is inside point. This is the exception in hyperbola. Everything is comparable from the remaining curves, but here s1 greater than 0 represents the inside point. And s1 less than 0 in the circle, parabola and ellipse, what I said, it is inside point, but here it is outside point. This thing also you have to remember, which is the exception from the remaining three curves, that is circle, parabola, ellipse. This is a position of point. Now I will discuss the important thing, that is the tangent equations. The tangent equations, which are of three types. That is, the first type is slope, not slope, it is the point. First important is point, after it is slope, point format. That is when point is given, that is x1 y1 point is given in the ellipse, and I have to suppose this is a point x1 comma y1, and I have to draw the tangent here. What I can do? I can draw the tangent. How? I already said what is this? X square by a square minus y square by b square minus 1 equal to 0. What is t? What is the transformed equation of this one? It will be xx1 by a square minus yy1 by b square minus 1 is equal to 0. This is the answer. This is a tangent. And this is a point format. What is a parametric format? Parametric format. When I discuss the parametric, I will definitely say what are the parameters of hyperbola. What are the parameters? The parameters are a secant theta, comma b tan theta, or the parametric coordinates. The circle have a cos theta, comma b sin theta. The parabola has a 80 square, comma 280, and the ellipse has a cos theta, comma b sin theta. Here I got a secant theta, comma b tan theta. You can substitute and verify. And the parametric format will be just substitute here. You will get x by a square into a secant theta minus y by b square into b tan theta minus 1 is equal to 0. Yes. So here a will get cancelled, bb will get cancelled. I will get x by a secant theta minus y by b tan theta minus 1 is equal to 0. Yes, this is a parametric form. Now comes the slope format. The slope format is in the slope format. It will be y is equal to mx plus or minus, everything will be same from ellipse and hyperbola. Whenever the equations are now changing to this type. How the equations are changing? The equations are simply wherever it is b square in the ellipse, now becomes it is b square. B plus b square will be in the ellipse, minus b square will be in the hyperbola. That's it. Wherever plus b square will be present, it is ellipse, and minus b square will be hyperbola. That is, when there is b square in the ellipse, just replace b square with minus b square. You will get all the equations of hyperbola. That is y equal to b mx plus or minus a square m square. One second. The things which I am discussing here is tangents. Equation of tangent. A square m square. I already said. There in the ellipse it is plus b square here, but we have to write minus b square. That is a change from ellipse to hyperbola. Yes, because in the equation only it is there. X square by a square plus y square by b square is equal to 1 is the ellipse equation. But x square by a square minus y square by b square is equal to 1 is the hyperbola equation. If you see, plus b square is changed to minus b square here. That is the reason here plus b square is changed to minus b square. So the entire equation becomes now the hyperbola. So remember guys, don't do the silly mistake, that is keeping the minus in the ellipse will give the answer of hyperbola. So you should not do that mistake. So I have completed the tangent. Now I will discuss the normal equations. What are normal equation? First one is point form. For point form, what is the equation? For point form, it will be a square x by x1 plus b square y by y1 is equal to a square plus b square. If you observe this equation, if I want to write an ellipse, what I have to do? Just replace b square with minus b square. That is a square x by x1 minus b square y by y1 is equal to a square minus b square. If you observe, this is the equation of hyperbola. That is a ellipse. This is ellipse and this is hyperbola. Yes, this is a point format. Now parametric format. Simply substitute the parameters, that is a secant theta comma b tan theta. What you will get? You will get I think it is ax by secant theta plus by by tan theta is equal to similar, that is a square plus b square. Same. Now comes the important equation, that is the third equation, which is of the slope format. What to write? The slope format, very important. What you can write the slope format? Y is equal to mx plus or minus m into, there you written a square minus b square. Here you have to write a square plus b square. Yes, in the denominator what you have to write? You have to write a square minus b square m square. There what we write? You have written a square plus b square m square you have written. But here there is a change. And here also there is a change. There is a change here and here. That's it. Everything will be the same as the ellipse. Everything will be same as ellipse. These are the equations. And if you go into the this one, I think I already explained here. Everything, this block is completed. That is a hyperbola. And I think important facts. In the important facts, I have explained this thing, that is eccentricity of hyperbola and the length of the latest rectum. There it is 2b square by a. Here it is also 2b square by a only. Here it is by 2b square a. But you can simplify this one and calculate as e square minus 1. And one more thing, what is hyperbola? When eccentricity is greater than 1, it is called hyperbola. Yes. I already explained the condition for tangent, that is c should be is equal to plus or minus a square m square minus b square. And the equation of the tangent at point is given as x1 by a square minus y by 1 by b square is equal to 1. This thing also completed. The equation of tangent at the parameters x by a secant theta minus y by b tan theta equal to 1. Yes, these things are very important. And the equation of the normal at this point is given as a square x by x1 plus b square y by y1 plus equal to a square plus b square. Yes, this thing also completed. Now in parametric form, that is ax by cos theta plus by by cot theta is equal to a square plus b square. And in slope format, the equation of normal is y equal to mx plus or minus. It is they said minus or plus, you can write plus or minus, and it is m into a square plus b square divided by root of a square minus b square m square. Very important. This is a main change from ellipse to hyperbola. What is the change? That is, we have replaced plus b square to minus b square. Very important. And I will discuss the one more important concept so that the entire conic section is completed. In the hyperbola, there is one concept. There is one concept called asymptotes. There is one concept called asymptotes. What is asymptotes? Asymptotes is nothing but tangent at infinity. Tangent at infinity. What is tangent at infinity? That is, suppose this is the hyperbola, and if I draw the line like this, if it meets the hyperbola at infinity, if it goes and meets, the point of contact becomes infinity. So what is the point of contact? It will be plus or minus a square m by c comma minus or plus b square by c. Yes, this is the point of contact. But this is the point of contact for ellipse. But in the hyperbola, there is no plus or minus. We can take direct answer. That is, the answer is a square m by c, a square m by c comma b square by c. What is c here? C is equal to root of a square m square minus b square. Now if you observe, this should be is equal to 0 in order to make the point of contact as infinity. So a square m square minus b square is equal to 0. So what you will get? M value. A square m square minus b square is equal to 0. A square m square is equal to b square. M is equal to plus or minus b by a. If I substitute directly, I will get equations as m equal to mx, y is equal to plus or minus b by ax. So these equations, that is y equal to plus y is equal to plus b by ax, and another equation y is equal to minus b by ax. These two are called asymptotes equations. Yes. Now everything will be changed. That is eccentricity. That is 1 plus b square by a square. How it is going to change? It will be 1 plus a square by a square. It will be root 2. This root 2 is the eccentricity. This root 2 is the eccentricity of rectangular hyperbola. Rectangular hyperbola. What is rectangular hyperbola? If when the transverse axis is equal to conjugate axis, the length of transverse axis is equal to conjugate axis. If the length of the transverse axis is equal to conjugate axis, then we can say that a hyperbola is called rectangular hyperbola, and the equation is xy is equal to c square. Very important. And for this equation, the parametric coordinates, the parametric coordinates are tt comma c by t. These are the parametric coordinates for rectangular hyperbola. These are the parametric coordinates for rectangular hyperbola, and I think this ellipse also, that is hyperbola, is also completed, and this hyperbola is also completed. I think I have completed the entire conic sections, and the definition, circle, parabola, ellipse, hyperbola I have discussed in one video, and the important facts also discussed, because these important facts is more important than the previous. But without the previous knowledge of the basics of the circle, parabola, ellipse, hyperbola, you cannot understand what are the topics here. Very important. And one more thing I have to explain, that is the common topics in all these things. Common topics. That is chord. Equation of chord is t is equal to 0. Chord with given midpoint. These are not present in the mind map. I am explaining extra because these are very important. Chord with a given midpoint. If the midpoint is given and you have to write the equation of chord, that is the equation is t is equal to s1. And the third point is you can think of pair of tangent equations. Pair of tangent equations are s into s1 is equal to t square. These three are the common topics. These three are the common topics in all the circles, ellipse, hyperbola, and circles, parabola, ellipse, hyperbola. T is equal to 0 here. These all things. These three, t equal to 0, t equal to s1, s into s1 is equal to t square. These entire three things are common in these four, that is circles, parabola, ellipse, hyperbola. So there is no need to again revise. These are the four things, that is circle, hyperbola, ellipse, parabola. So these four conic sections, which are circles, parabola, ellipse, hyperbola, if you want to understand these things, you have to watch the video of straight lines and pair of straight lines, because everything is the lines only. That is a tangent line, normal line. So you have to understand. So I have discussed the entire conic section, that is the circles, parabola, ellipse, hyperbola. And if you have any other doubts, you can comment it down in the TestprepKart YouTube channel comment section. And that's it for the video, guys. Keep learning, keep going. Thank you.